Assalamu alaikum, Dr. Iram Sayyed from Physiology department here. I will do the total leukocyte count with you. So the normal TLC in any individual, male or female, is between 4,000 to 11,000 per cubic millimeter. Any increase in the leukocyte count is known as leukocytosis, whereas any decrease in the leukocyte count is known as leukopenia. The leukocytes can be divided into granulocytes and agranulocytes. The granulocytes have granules, and they are the neutrophils, eosinophils, and the basophils, whereas the agranulocytes include monocyte and the lymphocytes. The neutrophils, eosinophils, and the basophils plus the monocytes are formed in the bone marrow, whereas the lymphocytes are formed in the lymphatic tissue of spleen, thymus, and the lymphatic tissue of the bone marrow. The learning objectives of this practical are that we can learn the total leukocyte count by the hemocytometer. We should learn to measure the total leukocyte count by the hemocytometer method. Number 2 is to get familiar with the different TLC ranges which occur in normal conditions, diseased conditions, and in conditions of physiological stress. The requirements are the hemocytometer, which is in which there is improved Newbar chamber or Newbar slide. Then we need a cover slip, we need WBC pipette, Turk's fluid, lancet, a spirit swab, and a compound microscope. The composition of Turk's fluid is as follows. 1.5 milliliters of glacial acetic acid is taken. This glacial acetic acid hemolyzes the RBCs and has no effect on WBCs. Then 1.5 milliliters of 1% gentian violet is taken. This stains the nuclei of the WBCs, and 100 milliliters of distilled water is taken. This is the composition of the Turk's fluid. The principle of this test is that first the specimen of the blood is diluted 20 times. This is done so as to ease the counting of the WBCs. Then using these values, formula is applied and WBCs are calculated in the undiluted blood. The WBCs are expressed as the number of WBCs per cubic millimeter of blood. Now we come to the procedure. In the procedure, what you have to do is you have to take a clean and dry hemocytometer, and you have to place the Newbar slide on the stage of the microscope without the cover slip. Then in the second step, you take the first you use the lower power and then the high power, and you have to identify the WBC counting area of that Newbar slide. Number 3, you take a clean new lancet and give a short, sharp, small cut on the sterilized finger of the patient. Number 4, once the blood drop appears, you discard the first drop. Number 5, then you allow a good sized drop of blood to form. After that, you have to place the WBC pipette at an angle of 45 degrees on it and fill the WBC pipette till the point 0.05. And number 6, we wipe off the finger of the patient with the spirit swab, and if need arises, we can apply a band-aid. Then we go to the dilution, which is the 7th step. In the dilution, what we do is that after filling the blood till 0.5, wipe off the excess blood from the pipette. Next, we insert the WBC pipette in the Turk's fluid and fill it till mark 11. Then we secure both ends of the pipette with your thumb and index finger and pronate and supinate the hand to gently mix the blood with the Turk's fluid. Another movement you can do is move the pipette in the figure 8, and that is also done to gently mix the blood and the Turk's fluid. Now the charging of the Newbar chamber is done in the following way. First we place a cover slip on the Newbar slide. Then we discard first 4 to 5 drops of fluid from the WBC pipette. This is done by dabbing it against a paper napkin. This is also done, the reason behind it is that the first 4 to 5 drops of fluid from the WBC pipette contain only the diluting Turk's fluid. Next, we place the next drop of the fluid from the WBC pipette at the edge of the cover slip, and this spreads under the cover slip with the help of the capillary action. This is how the charging is done. Then we let it rest for 3 to 4 minutes. During these 3 to 4 minutes, the WBCs, they settle down on the ruled square, and so counting can be easy. The counting of the WBCs is done in the following way. These are counted in the 4 larger corner squares present at the 4 corners of the Newbar chamber. Each of this corner square is further divided into 16 smaller squares. So this becomes 64 smaller squares, and the WBCs are counted in all of these 64 smaller squares. During the count, we have to see that we start from the left corner and then we proceed sideways, come to the next line and carry on until we reach the end of the 4 lines. This I have represented on the Newbar chamber, which I have drawn the direction of the counting. The second rule which is applied during this is that we apply the Thomas rule, and this is done to avoid any overcounting or double counting. In this rule, what we have to do is that the WBCs which touch the top and left borders of the Newbar chamber in each square are counted, whereas the right and the lower border, the WBCs which are touching the right and the lower border, they are not counted. As I have told you, this is to avoid any overcounting. Now we do the calculations of the total leukocyte count. We know that each side of the Newbar chamber is 3 millimeters. This square, which is formed by 3 millimeters length and 3 millimeters breadth, is further divided into 9 squares. Each square is now 1 millimeter, having 1 millimeter of length and 1 millimeter of breadth. So now if we calculate the volume of one corner square, the formula will be length into breadth into depth. So the length is 1 millimeter, the breadth is 1 millimeter, whereas the depth is known to be 0.1. If we multiply all these, we get a volume of 0.1 cubic millimeter of one corner square. Multiply it by 4 to get the volume of 4 corner squares. Now the WBCs which we have counted were in 4 corner squares. This means the WBCs counted in 4 corner squares is 150, or in other words we can say that in 0.4 cubic millimeters the number of WBCs is 150. To calculate how many WBCs are present per cubic millimeter, we divide 150 by 0.4, which is the volume of 4 corner squares. Now taking in consideration the dilution, which is 20 times, the calculations become as follows: 150 divided by 0.4 multiplied by 20. This gives us, simplifying, we get 150 divided by 4 multiplied by 200. And finally 150 into 50, which gives us 7500 WBCs per cubic millimeter. Lastly, we come to the precautions. Number 1, the hemocytometer, the WBC pipette and the cover slip. They should be clean and dry. Always use a new sterile lancet for every patient. Number 3, do not squeeze or milk the cut because this adds the tissue fluid to this blood sample and can vary the count of the WBCs. Number 4, always discard the lancet appropriately, which means discard it with the other sharp objects. Number 5, take care and avoid the entry of air in the WBC pipette because this will give erroneous results. And number 6, always decrease the light intensity of the microscope. This is to make the grid more prominent and more visible. So with this we come to the end of this practical. Please go through your journals. Please see this video which I am uploading, and then please come prepared in the live session. If you still have any queries, I will answer them in the live session, inshallah. Thank you.